We spent the last few days looking at how you can solve a system of linear equations. And so for the warm-up, let's review. List 3 methods you could use to solve a system of equations, finding the point of intersection. The first one we did was graphing. The second one was substitution. And then there was elimination. And so today we're going to review mainly elimination, but we'll take a look at all three. So here's the first example for B, the warm-up for B, solve the system. And remember, graphing you would want to use if both of them were y equals. And then you could type that in your calculator. Substitution, if you had one like x equals or y equals, and the other one maybe 2x plus 3y equals something. And you could substitute in. Elimination, you would want to use in this situation where x and y are on the same side, where they're stacked. If they're stacked like this, it'll be faster to solve by elimination instead of trying to get x or y by themselves. So we'll take a look at x or y. If it's elimination, you have to get rid of one of them, and you get to choose which one you want to get rid of. So this one you could choose x or y. I'll just choose x. Let's get rid of x. And I know that 6 and 3 both go into 6. So my goal here is to get them to look the same, except one should be opposite, so that when we add them together, one will cancel. So let's do that. Let's multiply the second one by 2, and we will get 6x minus 4y equals 7, and negative 6x if we distribute, plus 4y equals 16. If we take a look at this right here and add them together, the x's canceled as they should have, but if you take a look at this, the y's also cancel, and we get 0 equals 7 plus 16, which is 23. And we know that this is not true. 0 never equals 23. So let's talk about what this means. When you have something that looks like this, we could graph each equation, and what it's going to end up being is lines that never cross. Again, we're trying to find the point of intersection, and if they never cross, they're parallel lines. So again, we could graph this. If we were to graph it, it might look something like this, where the lines are parallel. In order to graph them, you would have to get y by themselves. So for example, if we had 6x minus 4y equals 7, you could subtract 6x from each side. We get negative 4 equals 7 minus 6x. Divide each side by negative 4. And we would get y equals negative 7 over 4 plus 3 halves x. You would do the same thing for the second equation, solve it for y. And again, if you were to graph them, you would get parallel lines. So when you get 0 equals some number it doesn't equal, it means your lines are parallel, and we say there's no solution. And the reason there's no solution is there's no point of intersection. That would be the solution where they cross. So we'll do a poll in class. Which method would you use to solve each system? Elimination, substitution, or graphing? For this one, substitution, you could very easily take this and stick it in for y. This one I would say elimination, because the x and the y's are stacked. This one I would use graphing because you have y equals for both. And this one again I would use substitution because you could substitute in for x. Review. Use your calculator to solve a system. So steps, solve each equation for y, open a graph page, enter it in, hit tab to enter in the second equation. If you don't see the point of intersection, here are the buttons you can press, and you can analyze graphs. So let's try that. Find the point of intersection on your calculator with these two right here. First step, solve for y, get y by itself. So we have 5y minus 10 equals 40x. We want to get y by itself, so we could add 10 to each side. 5y equals 40 plus 40x plus 10. Divide by 5. So we get y equals 8x plus 2. Okay, so there's the first one we'll graph. And the second one we'll do in a different color. Negative 2y minus x equals negative 40. Let's get y by itself, so we're going to add x to each side. Negative 2y equals negative 40 plus x. Divide by negative 2. We'll get y equals 20 minus x over 2. So I just moved this minus up top right here. All right, let's graph these and find the point of intersection. So I'm going to, I pulled up photos. I'll pull up my graphing calculator, which I should have had open, but I didn't. So I'm going to wait for this to load, and we're going to find the point of intersection by typing it in. Let's take a second. And I accidentally opened iPhoto, so I'm going to have to shut that as well. Okay. And while we wait, let's see what else we have here. Oh, write an equation in 2 variables. Okay. Okay, so let me open up, oops. Okay. Okay. So we're going to open up a new graphs page, add a graph. The first one was, oops, I minimized it. 8x plus 2. 8x. 8x plus 2. I enter, graph that. And the second one, 20 minus x over 2. Excuse me. So we would hit tab, pull down the graph, 20 minus parentheses x divided by 2. Graph that. We can't see it, so we're going to hit menu, window zoom. Let's zoom fit this. There's that point of intersection. We can calculate it. Menu, analyze graph, point of intersection. Go to the left and go to the right. Here's the point of intersection, 2.2, 18.9. So it's pretty easy to use if you can get y by itself. All right, last example that I want to go over, and then we'll start the assignment together. Mike had to go grocery shopping. He had enough fruit for 29 people. All right, let's underline that, 29 people. Ooh. Apples cost $1.49 each. Oranges cost $1.29 each. He spent $40.61 total before tax. How many apples and oranges did he buy? All right, I'm going to say apples are X, oranges are Y. And he had to get enough fruit for 29 people. So apples plus oranges equals 29 people. Apples cost $1.49 each, and oranges cost $1.29 each. And he spent $40.61. Here are the two equations, and you're going to solve. This one I would use substitution. Elimination with these decimals is kind of messy. So I would solve one of these for x or y. Let's solve for y. Y equals 29 minus x. Let's plug that in for y. And I forgot my y here. All right, so here's my y. We're going to plug it in. Here's what it'll look like. 149x plus $1.29 times 29 minus x equals 40.61. Go ahead and distribute this. You're going to multiply this out. So you're going to have $1.49x plus, and I'll need my calculator to calculate this. So $1.29 times 29, 37.41, minus $1.29x equals 40.61. Combine like terms, so $1.49 plus $1.29 is $2.78 equals, subtract 37.41 from each side, 40.61 minus 37.41. So we'll get, so this will be x equals 320, and divide that by 278. All right, and we'll get x equals, oh, I'm not getting a whole number. So I would have to double check my math. Let's see, 29 minus x looks good, $1.49, $1.29, 40.61, that looks fine. Let me just double check. $1.29 times 29, 37.41, 40.61 minus 320. Oh, I subtracted. I'm sorry, I made a mistake here. I added $1.49 and $1.29. I should subtract these two. So $1.49 minus $1.29 is 0.2. So we get 0.2x equals 320 divided by 0.2. 320 divided by 0.2 equals 16. Okay, so there's 16 apples. And to figure out how many oranges, we plug in 29 minus 16, and we get 13. So y equals 13, and this was oranges. And this was apples. All right, so I have a little note here that we should go over number 7 on the assignment together. So let me just set it up for you. Let me find it. Number 7 worksheet. Here we go. So number 7 on the assignment is right here. The class president is organizing a class trip to a nearby amusement park for 314 students. The regular price of the tickets is $35 per ticket. However, some students can receive a discount due to some community service they took part in. The students who are eligible for the discount will pay $21.50. The total ticket cost is $10,072. How many students are eligible? All right, so we're going to say that we have regular price is X and discount price is Y. So X plus Y here, the amount of tickets, 314 tickets. It's $35 for regular. It's $21.50 for the discount, and the total price was $10,072. So use substitution, kind of like we used for the last problem, and let's see if you can solve for how many regular price tickets and how many discount tickets there are.